Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we will discuss about context-free closure properties of context-free languages. In our previous classes, we already discussed about the pumping lemma for context-free languages. Please watch those classes and come back here. For better understanding, those classes will help you a lot. The link for the playlist is provided in the description below. Coming to today's class, we'll take an examples and understand the closure properties. Context-free languages are closed under union. So let's try to understand what closure properties means. Let's take two languages, L1, L2 are two context-free languages. L1 union L2 is also a context-free language. If you got that property that L1 union L2 is also a context-free language, then we say that context-free languages are closed under union. That is what closure properties means. Now we will prove it why context-free languages are closed under union. Take two context-free languages, L1 union L2. So the same two languages, L1, L2 are two context-free languages. L1 union L2 is given as strings from L1 or strings from L2. That is what L1 union L2 means. So if you write the context-free grammar for the language L1, assume that this is the context-free grammar for L1 and this is the context-free grammar for L2. We have chosen some examples not related to anything. So these are two context-free languages. Assume that we can write it as L1 union L2 can be written as see, the starting production is S1, the starting production is S2. We are taking an extra production S tends to S1 or S2. What's the meaning of that? You can choose S1, you can choose S2. That is what union means. You can select a string from S1 or you can select a string from language 2. Remaining productions are same. S1 tends to A tends to whatever the productions you have here. So we can write it, these two grammars can be combined, union, by writing this extra production. So that's why the context-free languages are closed under union. Coming to the next ones, context-free languages are closed under concatenation also. Take two languages, L1, L2 are two context-free languages. Concatenation means L1 followed by L2 means L1.L2 is given as strings from L1 followed by strings from L2. You take any string from L1 followed by any string from L2. That is what concatenation means. The same way in the previous example S1, S2, this can be written with an extra production called S tends to S1, S2 means strings from S1 followed by S2. That is what the meaning of this grammar production. So that's why it is closed under concatenation. Context-free languages are closed under clean closure. What is clean closure? Star operator, we call it as clean closure. So L1 is a context-free language. Assume that this is the language, this is the context-free grammar for the language. S1 tends to A tends to B. L1 star means strings from L1 and repeat. You take any string from L1, repeat this process. You can take any string from L1 or you can take epsilon. That is what star operator means. This can be written as you take extra production S tends to first S1 means this is the starting production. Remaining productions we have not written here. Usually you have to write the remaining productions down. Okay, S tends to S1. After that we are again calling S, means we are repeating the process. That is what clean closure means. We are repeating, or epsilon. That is what the meaning of clean closure. This is how we write a context-free grammar for the given language. Means L1 star can be written like this. So it is closed under clean closure. Context-free languages are not closed under intersection. So let's try to understand what's this not closed under the intersection means. Let's take a language L1 is equal to 0 power n, 0n, 1n, 2m. N greater than or equal to 0, m greater than or equal to 0. What's the meaning of this language? Zeros followed by equal number of ones followed by any number of twos. This is a context-free language. Here we are checking the equality for only 0 and 1. It is possible for context-free languages. This examples we already discussed previously. So this is a context-free language. Let's take another language. L2 is equal to 0 power n, 1 power m, 2 power m. N greater than or equal to 0, m greater than or equal to 0. This is also a context-free language. Yes, L1, L2 both are context-free languages. But the intersection of these two languages means you take any string from here, the common strings. Intersection means common strings. We will have only common strings in this format, 0 power k, 1 power k, 2 power k. You take one string, 2 zeros followed by 2 ones followed by 2 twos. That is the string which is having common here also. Only those strings will have common, equal of strings, those will be in common. If you take the intersection of these two languages, you will understand that 0 power k, 1 power k, 2 power k, where k greater than or equal to 0. These are the strings which we got after intersecting of these two languages. But in our last class, pumping lemma, we showed that this is not a context-free language. So that's why L1 intersection L2 is not a context-free language. It is not closed under intersection. Okay, now coming to the next one, context-free languages are not closed under complementation. Complement. L1 intersection L2 can be written as L1 complement union L2 complement whole complement. We already proved that union is closed under context-free languages are closed under union. If you assume that complement is also closed under in context-free languages, then this is a contradiction. We already proved that L1 intersection L2 is not closed under context-free languages. Context-free languages are not closed under intersection. Then this is a contradiction. That's why complement is also not closed under in context-free languages are not closed in complement. Similarly, context-free languages are not closed under difference. L1 intersection L2 can be written like this: L1 minus L1 minus L2. If you assume that minus is closed, then this is a contradiction. So minus is also, set difference is also not closed under in context-free languages. Set difference is also not closed. That is what the meaning of that. Next one is context-free languages are closed under reversal. What's the meaning of reversal? Means reverse of a language. So we are not discussing what's reverse of a language. We already done in our previous classes. L1 is equal to 0 power n, 1 power n. This is a context-free language. Reverse of a language means write it from this side. So if you take the context-free grammar for this language, S tends to 0, S1 or 0, 1. So the reverse of the language can be written like this: L1 R is equal to, you reverse the productions, 1 S0, 1 S0, 1 0. Yes, you will get the reverse of the language. So that's why it is closed under reversal also. Context-free languages are closed under homomorphism. Means you substitute some symbols in place of your input symbols. That is what homomorphism means. S tends to 0, S1 or 0, 1. This is the context-free language for a power n, 0 power n, 1 power n, where n greater than or equal to 1. So if you want to substitute h of 0 is equal to ab in place of 0, if you want to substitute ab in place of 1, if you want to substitute epsilon, what's the, yes, if you substitute it, we'll get a context-free language. How you get that one? In place of these productions, wherever you have 0, substitute ab, abs. These are the productions that produce the same whatever the substitution strings. So that's why it is context-free languages are closed under homomorphism. So these are the properties. Hope you understand the concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.